All right, you're live.
Okay, so for question 1, the group of enzymes that link amino acids to the tRNA are called aminoacyl tRNA synthetases. Proteins that consume GTP are elongation factor G, EF2, and initiation factors 2 and 3. The molecule that functions as a ribozyme is peptidyltransferase. 2 proteins that recognize the stop codon are the release factors 1 and 2. And the molecule that bonds with the Chenet-Delgarno sequence is the ribozyme, or specifically the small ribosomal subunit, or 30S. The first amino acid in a prokaryote is N-formylmethionine, or FMET. The protein that delivers tRNAs to the ribozyme is EF2. The tRNA binds to the P side of the ribosome, and that's the initiation part. And then the charged tRNAs bind to the A site of the ribosome. The translation factor that helps the ribosome move in the 3' direction is EFG, the elongation factor, and the translation factor that guides the mRNA to the 30S ribosomal subunit is IF3. Start codon is 5' AUG 3'. Some examples of stop codons are 5' UAG 3', or 5' UAA 3', or 5' UGA 3'. The term that indicates that several codons can specify for the same amino acid is degenerate, and the C terminus of the polypeptide contains the final amino acid.
And for question 3, it asks you to provide all possible tRNA anticodon sequences that can form hydrogen bonds with each mRNA codon. So the first one is 5' UUG 3'. And so the sequences all go 3' to 5'. And the first one is AAC, the second one is AAU, and then AAA. And then B is 5' AGU 3'. So the sequences are all 3' to 5' again, and the sequences are UCG, UCA, UCU, and UCI. And then for C, the sequence is 5' UAC 3'. So the sequences are 3' to 5', and then you've got AUG, AUA, AUU, and AUI. And D is 5' AUU 3', and then your sequences are 3' to 5', and you've got UAA, UAG, UAU, and UAI. And then you've got the last one that's 5' GCA 3', and the sequences that we come up with are 3' to 5', and it's all CGU, CGA, and CGI.
All right, so question 4, it says that a protein X weighs 218 kilodaltons. So if the average amino acid is 125 daltons, then how many amino acids are found in protein X? So the way to solve it is you convert 218 kilodaltons into just daltons. So you take 218,000 and you divide 125, which is the average weight of the amino acid. And that gives you the total number of amino acids, which is 1,744. For part B, it's asking the length of the mRNA. So it takes 3 base pairs to make every amino acid. That takes 3 to make up a codon that code for the amino acid. So you take 1,744 times 3, and that gives you 5,232 base pairs. If you want to know the length of that in meters, base pairs are 0.34 times 10 to the negative 9 meters apart. For C, it's asking how many GTP are synthesized to make the protein X. And there are 1,744 total amino acids. So we take that times 2, which is the number of GTP that are consumed for every step in elongation. So take that times 2 plus the 2 for termination and the 1 for initiation. That gives you a total of 3,491 GTP. For D, what we found was that there's only one ATP consumed for the production of every amino acid. So you again have just 1,744 ATP used for the production of protein X. For E, it's saying what is the name of the enzymes that consume ATP. So what are the enzymes that actually use ATP when making this protein? It is aminoacyl tRNA synthetase.
The last question, it gives you a list of proteins and nucleic acid sequences involved in translation, and then we just have to figure out which one is in different parts. So the first question is, which of the above is involved in translation and initiation? We did IF2, IF3, 5' AUG, 3' tRNA, FMET, time Delgarno, and 16S rRNA. For B, it asks which of the above is involved in the translation elongation. And we said EF2, EFG, 16S rRNA, 23S rRNA, lysyl tRNA. And for C, it asks which of the above is involved in translation termination. We said RF1, 5' UGA, and 3'. And then we said, sorry, and then the question is which of the above is a component of the 70S ribosome. And we said rRNA, 23S rRNA. And the last question is which of the above is found within the mRNA, and we said Shine Delgarno and 5' EGA 3', and 5' UAG 3'.